Hello, Professor. I'm Ray. Now I'd like to start explaining the code for assignment 2. This is the data set of the processing in assignment 1, and it's what I used. It's what I used for assignment 2. The first step is to add a new column called shipping delay. It is calculated by subtracting the order date from the ship date, which gives me the time it takes to ship an order. Based on the analysis from assignment 1, I found that shipping delay is one of the features that can affect the profit. And the next one is feature selection. Based on the initial analysis in assignment 1, I identified which columns are related to perfect and which one are not. So here I removed all the unrelated columns and keep only the relevant ones, such as this is done using this code, such as the feature I selected is segment, category, region, discount, quantity, sales, profit margin, shipping delay, and profit. And after selection, I can get the table like this, the data set like this. Just keep only the relevant features and remove all the irrelevant features. And then is recording the text columns. Convert the relevant columns such as segment, category, and region into one-hot encode variables. This allowed me to use them in machine learning models for prediction. And this is done using this code. Then we can get this one. You can see all of the feature columns transform into number. And I got a clean data set like this. I also checked the data types of each columns to make sure everyone is in neural is in like numerical format. Yeah, you can see that the data type is right here, and every columns is numerical format. Which is suitable for machine learning algorithms. And next one, I made 4 copies of the dataset, and they are used for training and tuning 2 different machine learning models and for making prediction with each of them. The 1 copy is right here, the 2, and the number 3, number 4 is for optimization and prediction for both two different machine learning algorithms. And in this assignment, I used 2 algorithms, XGBoost and Random Forest. to predict the perfect values. And in the XGBoost part, I first in this part I first split I first split the dataset into training and testing. In the training and testing set using 80 and 20 ratio. 80 and 20 ratio, and the test set I set equals 0.2. And then I created a pipeline that includes the data standardization and the XGBoost regressor. And next, instead of using the default hyperparameters, I selected the several key ones to tune to optimization. Here you can see the range of values I used for optimization. And to search for the best combination, I used the random search CV. And I also wrote a loop. To log each hyperparameter combination along with its evaluation metrics, such as MSE, R-square, Pearson, and Spearman. Yes. So I could check the performance of each models during the tuning process. And in the end, I created a table that looks like a log. Is this one? It looks like a log, optimization log. It contains each hyperparameter combination. Each hyperparameter combination is right here, and along with its evaluation score is right here. MSE, R-square, Pearson, and Spearman's. There's also a column called its best that shows whether the combination is the best or not. For example, if its best is false, that means it's not the best one. But if it is true, like this one, the number 19, that means this hyperparameter combination is the best, such as the subsample is equals 1, the n equals 100, the minimum child weight equals 3, such as that. Okay. So let's move to the next one. For the random forest model. And for this model, I follow the same process, like splitting the dataset into the same test sites, defining a pipeline, tuning hyperparameter, and evaluate and logging the results. So I will not repeat the detail here, and the only different was the range. The only different was the range of hyperparameters I used for optimization. And in the end, I can also obtain similar log style tables showing all test hyperparameter combinations and their evaluation scores right here for random forest algorithms. which help me identify the best side of hyperparameter. Like this is best equals true. That means the number 12 is the best hyperparameter combination. And next, I use the best hyperparameter combination to build a new regressor. You can see the hyperparameter I set the best one. I follow the same step as before, like split the data set, defining pipeline, training model, and making prediction. Then I combined the predicted value with actual value into a single table, which I used for further evaluation. It's right here. We can see the actual value is right here. The text value and the predicted value is right here, and we can do more evaluation in the future. And next, I calculate the future importance for both models using the best hyperparameter combinations. I recorded the importance score of all features into a table and sorted them in descending order. It looks like this. This feature importance table clearly shows which feature have the most impact of prediction and which is useful for providing business insights in the next step. You can see by using XGBoost algorithms, the most important one is region east, and the second one is profit margin, and etc. But for random forest, the most important one is sales, and the second one is profit margin. And finally, I use the table containing both predict and actual values to create two visualization in Power BI. And this one is for XGBoost, and this one is for random forest. And this chart clearly shows the predictions results and help with performance evaluation. Okay, that's all from me. Thank you for your listening.